All right, we were on number 4 from page 287. We had already simplified the equation. We had that it has a speed at the bottom and it has a height at the top and everything else cancels out. And now when we get here, 1/2 mv initial squared equals mgh as the m's go. And we're looking for the height, so we can just divide by the g. So h final will equal 1/2 v initial divided by g. So 1/2, and the v initial is 10 meters per second squared divided by 9.81 meters per second squared. So on the top is 50, on the bottom is 9.81, and you should get then a height, final, of 5.0 equals 5.0968 meters. Okay, number 5. It's the one that's a little bit tricky because it's a pendulum. So a wrecking ball with a mass of 315 kilograms, so 315 kgs, hangs on a crane. The cable is 10 meters long. So this length is 10 meters, and coincidentally, so is this length. If the crane swings the wrecking ball so that it makes an angle with a vertical of 30 degrees, so this is 30 degrees, what is the potential energy? What will be the kinetic energy? What is the speed? So when you have a pendulum like this, because that's what this wrecking ball is, draw a line so that you can form a right angle triangle, okay? And the right angle needs to be with the rope from the pendulum hanging straight down and the line that you're drawing across parallel with the lines on your paper, okay? Above this line you drew across, then, this section of the length of the pendulum we're going to call y. And we can find it because we know the hypotenuse, it's 10 meters. We know the angle, it's 30 degrees. We want the adjacent side. So we would do cos of 30 is equal to adjacent y over hypotenuse 10. So y is equal to 10 meters cos of 30. And the cos of 30 is 0.866, so y is equal to 8.66 meters. How does this help us? Well, it helps us because if this section's y, then the piece below the triangle to the ball, that's your h, and it's going to be like your h final, right? Because this ball is going to swing up until it eventually stops up here. So we can find our h final, because if we know this section's y and the whole thing is 10, then h just must be 10 meters minus y. So h final will be 10 meters minus y, or in other words, 10 meters minus 8.66 meters. So h final will be 1.34 meters. How is that helpful? Because now if we have that, that's its height up here, so now we can find its potential energy, gravitational potential energy up there, which is what the first part of the question says. What will be the potential energy of the wrecking ball in relation to its lowest position? So we'll assume down here h equals 0, and we just found the final. So it only wants gravitational potential energy, so we can actually do Eg equals mgh. You don't have to do the big long equation yet. So Eg equals 315 kilograms times 9.81 meters per second squared times 1.34 meters. And you get gravitational potential energy of 4,140.016 joules. That's the first part of the question. They don't do it A, B, C, but if they did, this would be A. B says, what will be the kinetic energy of the wrecking ball when it falls back down? So it has 4,140 joules of energy up here in its gravitational potential. As it swings down, it's going to lose that, but it's going to pick up speed. And the further it swings, the faster it goes, so the more kinetic energy it has, but it's losing height, the less gravitational potential energy it has. When it gets to the very bottom where h is 0, then all of the gravitational potential energy is gone. Well, where did it go? It shifted into kinetic. So for part B, EK at the bottom must be equal to EG at the top. So EK then is equal to 4,140.016 joules. And you don't actually have to do any work. You just have to say what I said there. EK at the bottom will equal EG at the top. That's part B. Part C says, what will be the speed of the wrecking ball at that spot? Well, if we have you could do the big long equation if you want it and solve it, or you could realize you have EK, and you know EK is equal to 1/2 mv squared. So v squared is going to equal 2 EK over m. So 2 times this 4,140.016 joules divided by the mass, which was 315 kilograms. And remember, that's going to give you v squared. You are going to have to take the square root. So you get 26.2858 before the square root. And after the square root, you get 5.127 meters per second. Okay, the one other one on that page that you could do that I didn't assign was number 7. I'd probably skip number 6 and number 8 just because they're a little weird. Okay, but if you wanted to try number 7, you certainly could. And the back, I don't know if the back of the book is right or not, but it's just an inclined plane. And it's going from a box is up here at the top. There's some length L that in the end you're going to find. This angle is 25 degrees. It tells us the mass. It tells us the initial speed up here at the top is 3.2 meters per second. We don't know the height up here. We know the speed at the bottom, the final, is 9.7 meters per second. And we know the height down here is 0. So we're back to our big equation, 1/2 mv initial squared mg h initial 1/2 k x initial squared equals 1/2 mv final squared mg h final 1/2 k x final squared. Still no E lost. So it goes, still no spring. At the top, it has a speed but no height. At the bottom, it has, oh, sorry, the height, it does stay. It's what we're looking for. Pretend that's not scratched out. At the bottom, it has a speed and no height. So we have left then 1/2 mv initial squared plus mg h initial equals 1/2 mv final squared. You might want to pause this and see if you can finish it and then restart me. M's cancel. And you're looking for the height at the top. So it'll be GH initial equals 1/2 V final squared minus 1/2 V initial squared, and then you're going to divide by G. So H initial equals 1/2. Final was 9.7 meters per second squared minus 1/2 3.2 meters per second squared divided by 9.81 meters per second squared. HI equals 4.27 meters, but that is not what the question asks. So we now have this height, 4.27 meters. We have the angle. We want the length of the hypotenuse. So you have the opposite side, so sine of 25 will equal 4.27 meters over L. So L will equal 4.27 meters over the sine of 25. And when you do this, you get an L of 10.11 meters. Okay, so hopefully these are pretty good. I think it's probably time to add in springs.